Today I want to take a look at linear equations. This is probably one of the easier concepts for students to understand, but probably it's also one of the least understood concepts for students coming into university. It's something that is quite simple that you should be able to apply to any set of data, but what I see from a lot of students is they have trouble understanding how to apply it, what to get out of a linear equation, and so forth. And so today what we'll do is we'll take a look at linear equation and how we can use it, and specifically the fundamentals of a linear equation, what goes into it that will allow us to do more complicated things in the future. The first part that I'd really like you to understand about a linear equation is how to determine the slope. So what I've found is a lot of students have problems with calculating the slope or understanding what the slope means. So if we can start as a basic point to determine the slope, then when we start to get into more complicated stuff, then we can start to use that slope to do different things. So the first point that I want to clarify is how to determine the slope. So what I'm going to do is I have a figure shown here, and I want you to pause the video, figure out what is the slope, and then leave your answer in the comments. And then as I go through the calculation, then you can double check your answer and see that you understand the concept completely. So I'll pause it here, put your answer in the comments, and then play the video and see if you're correct. The way that I learned to determine the slope of a line is rise divided by run. So rise over run. So what does rise mean? So rise I think of as vertical. So how far do we have to go up from the lower point to the upper point? And so I'm looking at rise in terms of the vertical y direction. So positive in the direction of positive y. So you can see this is positive y, this is negative y. So I'm going to go from positive to negative in that direction. What is run? Run is the horizontal distance, so along the x-axis. So instead of looking at the y-axis, now I'm looking at x. So now I'm going this way, but also in the direction of positive x. So you can see this is positive x, that's negative x. So this is my run. So rise is vertical, run is horizontal, and then you can determine between the 2 points what is the slope. Now let's get into the calculation of our slope. Okay, so we have to figure out rise over run. So this is the lower point, this is the upper point. So we're going from the bottom point to the upper point. You can also do it the other way around. What is the rise to go from the lower point to the upper point? So if I draw a horizontal line to the bottom point, my y value is -4. And you should be able to see that the y value of the upper point is +4. So how far do I have to go to get from -4 to +4? Well, -4 minus a -4 is +8. So my rise is going to be 8. So that's 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. So now we need to look at our run. So how far do we have to go horizontally to get from the first point to the second point? So if I draw a vertical line, the x value of my first point is -3, and the x value of my second point is 0. So how far do I have to run? Well, I have to go from -3 to 0, so I have to go 1, 2, 3 units. So my run in this case is 3. So what is the slope of our line? Rise divided by run equals 8 divided by 3, which equals about 2.67. So this is 2 2/3 or 2.67. Go back, double check your answer. If you didn't get the correct answer, then look at my calculation, make sure you understand how I did it, and so then you should be able to understand how to calculate the slope of a line, and then we can move forward from that point to do more complicated stuff with the slope. What do we use the slope to do? And actually in engineering, we use the slope to do a lot of different things, especially when we're looking at graphing our data.